All right, this is AP review, and we are doing 2016 ABBC free response number 1. So this is a table problem. Right away, first off, it's calculator, which is nice because those are some big numbers, and also they gave me a really ugly equation. But second thing you should consider is that it's very, very likely that you're going to be asked to either find, or maybe both, but either find the derivative of r, which would be r prime of t, approximately by using the slope of values on the table, or you might be asked to find the approximate integral of r of t by using some sort of area approximation method, like trapezoidal, LREM, RREM. That's what you usually see on a table problem. You may not see it, but it's good to know going into a table problem that there's a good chance you'll be asked to estimate the slope of this thing by using old school slope between 2 points, and there's a good chance that you'll also be asked to estimate the area under this thing using trapezoidal or LREM or RREM. Okay, so part A. Oh, sorry, I should read you this giant long problem. Water is pumped into a tank at a rate modeled by W of t, which is this thing, in liters per hour, where t is measured in hours. Water is removed from a tank at a rate of r of t, which are some of the values given in the table. So right away, I want you to note that this is the rate in, rate out. So rate in, rate out. So this is a rate in, rate out problem. We've seen a bunch of them. It doesn't matter if it's people getting on the line for on the line for an escalator and going up the escalator and getting off, or people getting in a line for an amusement park ride and going through the ride and then leaving, or whether it's people putting bananas on a fruit stand and taking the bananas off, or any number, snow and falling and being shoveled. It doesn't matter which thing it is. These rate in, rate out problems are pretty common. Okay, so we know that r is differentiable and decreasing, so r is decreasing the whole time. Selected values of r of t are shown in the table above. At time t equals 0, there are 50,000 liters of water in the tank. Okay, part A, estimate r prime of 2, show the work that leads to your answer. Right, so the first thing I mentioned that you might have to do is estimate the slope of this thing, right, using old school slope. So we don't have the point 2 on our table, but we have 1 and 3. So I'm going to use r of 3 minus r of 1 over 3 minus 1. I'm going to use old school slope, and I'm going to put a little approximate symbol, right? So that's a 950 minus an 1190 all over a 2. It is a calculator section, so there's no reason to make your life hard here. You showed the work. You get a negative 120 liters. So it's liters per hour or liters per hour squared. Either of those would be fine. They did not ask you to explain what it means. They just asked you to use the correct units of measure, which is great. So part B. Oh my gosh, it's like I'm psychic. Use a left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this an over or underestimate of the water removed? Give the reason. Wow. So the two things that I said would happen with a table, totally happening with a table. So in order to estimate the amount of water removed, you would want to integrate, right, r of t dt from 0 to 8. So to approximately do that, they asked us to do a left Riemann sum. So what that means is on each interval, they have a width. So from 0 to 1, the width is 1, because 1 minus 0, right? And then I use the left y value as the height, right? So width of 1, the left y value is the height, right? Plus the next interval has a width of 2, because it's from 1 to 3. And then I use the left y value as the height, because it's LREM, right? The next interval has a width of 3, because it's 6 minus 3. And then I use the left value, which is the 950. And then the last interval has a width of 2, and I use the left of the two y values, which is the 740, right? I never end up using the 700, which is the one all the way to the right. Again, this is a calculator section, so write this out. Great. And then you can get that your answer is 8,050 liters, right? Now they ask, is it over or under? So the trick here is that they told you specifically that r of t is decreasing, right? So since r of t is decreasing, right? If you picture what a decreasing function looks like, if you were to use left RAM on a decreasing function, the left y value is always physically higher than the rest of the graph because the function is decreasing. So what's going to happen is, since the left y value is physically larger than any other value in the interval, right? LRAM is an overestimate. Okay, so LRAM is an overestimate because, again, these left y values are higher than the right because the function is decreasing. So I need to state that it's because r of t is decreasing, which they went out of their way to say at the beginning. Cool. Part C. Use your answer from part B to find an estimate for the total amount of water in the tank to the nearest liter at the end of 8 hours. Okay, so here's the thing about water in the tank, right? So we'll keep that 8,050 in the loop, right? And I probably don't need the table anymore, but who knows? So we just won't. So we just won't erase it. So here's the deal: if I want the water in the tank at t equals, at the end of the 8 hours, so at t equals 8, right? The end of the 8 hours. What that's going to be is that's going to be the starting amount of water, right? The amount of water that started, right, in the tank, plus the amount that was added, right, like the amount gained, okay, minus the amount that was lost, right? So that's always what these problems boil down to. So now we just need to find a mathematical way to write this information. So we were told that the starting amount was 50,000. That's great. We just figured out how much water was removed. It was approximately 8,050, right? That was our answer to part B, right? So part B. And then to figure out how much water went in, what we would want to do is integrate the rate in. So it would be the integral from 0 to 8 of W of t dt. So this is what the AP needs to see you do. And then they understand that you're going to type it in your calculator and get an approximate answer, right? And that's fine, and it would be liters because it's the number of liters in the tank. So when you go to type this in, the first thing I did when I saw this problem is I put W of t in my calculator as y1. So I put y1 in as this thing with x's, right? So 2,000 e caret negative x squared over 20, okay? So the way I'm going to type this in is I'm going to type in function integrate y1 with respect to x from 0 to 8. And that is what's going to give me this value, right? So I can type in the 50,000 ahead of time and the minus 8,050 after, or I can just, it's up to you. You can type it all in one row if you want, or you could just find this guy and then deal with adding the numbers. So I have my 50,000 plus math 9 of bears function y1, comma, with respect to x from 0 to 8. Now, the one thing I will say that is advantageous about doing this separately by itself is it can flag if something's wrong for you. Like, let's say you accidentally type something wrong and you get that this is negative, which it shouldn't be because it's the amount of water gained. You're not going to notice that right now because of the 50,000. Like, you might miss it. So if you're afraid you might do something wrong, it's not a bad idea to find this value first and make sure that it makes logical sense in the context of the problem, and then add the 50,000 and subtract the 8,050. So let's actually do that just in case, because that seems safer, right? You just don't want to risk, we all do stuff that's crazy sometimes. So I end up getting that we gained like 7,836 and some change. I'm going to add to that the 50,000 that started originally in the tank. Cool. And I'm going to subtract the 8050 that came out, and I get 49,786 point stuff. Now, they say in the problem to the nearest liter. So I'm not rounding to 3 places. I normally would, right? So I end up getting that this is 49,786 liters because they said to the nearest liter. They don't want the 3 decimal places. All right, last part D. For 0 to 8, there is a time t when the rate at which the water is pumped into the tank is the same as the rate at which the water is removed from the tank. Is there. Explain why or why not. Okay. So what they're asking is there a time? So they're saying, is there a time in the window from 0 to 8 for time, right, that W of t equals R of t, right? So we know that R of t is differentiable, right? So they said differentiable, which implies continuity, right? You can't be differentiable unless you're continuous, okay? We also know that W of t is an e to the x function, so this is a continuous function, and you can see that it's continuous and it's just fine, right? So both functions are continuous. So the question is there a time when they have to be equal? So if I wanted to find, so my argument here is that I know R of 0 is 1340. And if I plug in W of 0, and I can do that in my calculator, right? It's actually my y1. So if I want to be kind of lazy about it, I'm letting it graph now. Right? I could actually trace. I mean, I could also just plug in 0, but if I hit trace and then hit x is 0, it'll tell me that originally W of 0 is 2,000, and that makes sense if you plug in the value. I know that R of 8 is a 700. If I plug in W of 8, so if I hit trace and hit 8 and hit enter, it'll give me a value. W of 8 is an 81.524. So here's my argument. If both functions are continuous, and if originally W is physically higher, so just to give you an image of what this looks like at 0 and 8, W is the higher function, right, and then drops down to be like 81 something. So W I did in blue, right, so W. R, which I'll do in green, right, R started lower than W, but landed higher than W. Well, the only way that can happen is if they cross at least once. So the easiest way to point this out is that because W of 0 is greater than R of 0, and W of 8 is less than R of 8, and both functions are continuous, W of t has to equal R of t at some point in the window from 0 to 8, right? Now, the AP asks you to do it using the intermediate value theorem, which is just fine. One of the ways that the AP asks you to do it using the intermediate value theorem, which is probably better than mine, like my explanation might fly, it might not. They want you to consider essentially the relationship between W of t and R of t. So the way that the AP suggests doing it is they suggest that you consider that W of t minus R of t equals 0. So at t equals 0, right, W of t, so W of 0 minus R of 0 is positive, and at t equals 8, W of 8 minus R of 8 is negative. So by the intermediate value theorem, W of t minus R of t equals 0 somewhere in that window from 0 to 8, which is saying W of t equals R of t. So that's the way that the AP did it. I might have gotten an 8 out of 9 on this one if I didn't use the intermediate value theorem. So frequently when they want you to show why something must equal something else, they want you to do it using the intermediate value theorem. In this case, the easiest way to do it was to use W of t minus R of t.